Yep, so hi everyone. My name's Kai North. I'm a third year PhD student here at George Mason University. I specialise in educational technology, and within that I look particularly at text simplification or lexical simplification, which is another subfield within inside that. Today I'm going to talk about what the kind of research I'm doing here at George Mason, and I'm particularly going to be focused on one paper we recently got published at Coling, and just kind of summarise that for you guys and give you a brief introduction. So first off, what is text simplification? What is lexical complexity prediction and stuff like that? Well, the first thing I need to talk about is complexity. Now, when I mention complexity, I mean how difficult a particular text is to read, understand, perceive, and that kind of stuff. And this can be in relation to the syntax of a text, its grammar, its morphology, or in particular, its vocabulary or jargon. And that's specifically what I'm interested in. And now, particularly given this example here, bombardment by regime forces. Now, text simplification, the idea is to simplify particular hard to understand words in that phrase so it's easier for certain target demographics to understand. We're talking children, second language speakers, perhaps people with reading disabilities like aphasia or dyslexia. So when I say complexity, for instance, the word bombardment would be considered complex or difficult to understand for a certain target demographic because it may be unfamiliar, it could be infrequent to them, or it's simply learned at a later age. Now, why is lexical simplification important? Why is it interesting? Well, it means that, or measuring complexity means that we can simplify text. And there is a higher demand for more accessible text due to the increase in distance learning and increase in educational technology as well, primarily to do with code and areas like that. So to give you a working example of what lexical simplification exactly is, when given a particular complex sentence, again, the bombardment by regime forces, the first thing we need to do in the LS pipeline is to recognize which words within that phrase are complex. So CWI submodule, again, this is a machine learning model trained to recognize complex words, would recognize the word bombardment as being complex. The second step is to go to substitute generation, where we generate a bunch of alternative candidates or simplifications, words like assault, raid, attack, which fit in that particular context as well. And then the next part is to select out of those candidates which ones are the most appropriate. So from assault, raid, and attack, we can get rid of raid. Maybe that's not particularly what is meant in this context, so we can ignore it. And then we go on to substitute ranking to find out which of those candidates is the best. Of course, selecting attack over assault with a simplified sentence of the attack by regime forces. Again, making that more easier to understand on the fly or to a particular target demographic. So why have we come into this area, or this, where does this paper come into this field of research? Well, we introduced Alexsis PT, which focuses mainly on lexical simplification for Brazilian Portuguese. Now, this data set is a bit different to previous data sets, and where it is better is in terms of the number of annotators we use to collect our sample and the number of simplifications it provides. So previous data sets, I've used a very minimal now of annotators in the data collection. Sometimes it was only 3, sometimes it was 5. We went a little bit overzealous and collected 25 annotators. Why did we do this? Well, we wanted to do this to generate more potential candidates to that original complex word. There's also another data set which is twinned with Alexsis PT, known as Alexsis, which kind of followed the same methodology. We're quite interested here because we want to do some transfer learning between Spanish and Portuguese, relatively similar languages. So to give you an example of Alexsis PT and what it actually contains, we have the particular context or the sentence we want to simplify. We provide that context to our annotators, who we got from Amazon Mechanical Turk. We highlighted the complex word, and we asked them to provide a bunch of simplifications to that complex word. So my Portuguese is not great, so I've translated it for English. So if the sediments are carried to the lower part of the river, the annotators provided waste, debris, garbage, and fragments. And then we rank these words in order of their suggestion frequency by the annotators. We did not only have single word suggestions, we also included suggestions which were multiple word or multi-word expressions. So for instance, in the last example, This year, 4 simultaneous actions will occur. The annotators also provided the phrase at the same time. So the idea is, with machine learning, we can, for instance, using a thing called masked language modeling, we're able to generate those gold candidate substitutions, which I just showed you guys, through this approach, and in this way, conduct lexical simplification. So the idea of masked language modeling is obviously you provide 2 sentences in this particular domain, in LS. You provide the original sentence. You collocate that with another sentence where you mask the words you want to replace. And then obviously it will produce a bunch of candidates which you can then evaluate to the data set. We evaluated our data set using a variety of different models, Batimbu, XMR, MBERT, all variations of the Sesame Street family of Bert, Roberta, and so forth. We found that Batimbu performed the best on our data set, primarily because it pre-trained on a large amount of Portuguese, specifically Brazilian Portuguese data. We're hoping that other models, particularly multilingual models, would be able to use other languages and a bit of transfer learning there to maybe produce good candidates. What we found is the candidates in those used by those models weren't always in Brazilian Portuguese, so they were not of any use to us at all. So even though, I don't know if you guys can see that from far back, but even though the performance does not look particularly too impressive, what we are trying to rate here is the accuracy of the top K1. And top K1 is that one gold label, the first gold label we're trying to predict. So even though the performances are quite small, this is kind of normal within the field of lexical simplification. Yes, but one thing to keep an eye on is the potential. Now, the potential is a ratio of the candidates produced, which were within the gold labels. So even though F1 recall and precision are relatively low, the high potential means that